So this lesson is some factoring review. All of this type of factoring we have seen before, so hopefully this will just jog your memory. So the first thing that you do when you're factoring is always look for a GCF first. Always look for GCF first. Very important rule in factoring. So looking at our first example, 49 and 64 don't have any common factors, and neither do A and B. So we have no GCF. So then what you want to look for, if you have a binomial, remember, is a difference of squares. 49, A squared, 64, B squared, all perfect squares. So when we're factoring perfect squares, difference of perfect squares, we factor into conjugates. So remember, what we do is we take the square root of the first term, and I set up my two binomials, and I usually write it twice. And then you take the square root of the second term, one positive, one negative. Those are conjugates when the binomials are the same, but one is positive, one is negative. So remember how this works real quickly. The 7a times 7a will give us the 49a squared. The 7a times negative 8b will cancel with the 7a times positive 8b. And then the 8b times negative 8b will give us the negative 64b squared. So those middle terms end up canceling. With factoring, you can always check to make sure that you got the correct answer by distributing it back to see if it matches what you started with. If it doesn't match what you started with, find your mistake. All right, B, step 1, always look for GCF first. 3 and 300 both have a GCF of 3. X cubed and x both have a GCF of x. So we're going to divide that out of both terms first. 3x cubed divided by 3x gives us x squared. 300x divided by 3x gives us negative 100. And always, after you find a GCF, always ask yourself, can I keep factoring? So now we're going to look at that binomial, x squared minus 100. Well, it's a difference of squares, so we're going to factor those into conjugates. So square root of x squared is x, and the square root of 100 is 10, 1 positive, 1 negative. In either order, notice I used a different order, for example, A and B. Doesn't matter, you can multiply in any order. Next type of review that we're going to look at is the T-table method and the AC method. Step 1, anytime that you are factoring, always look for a GCF first. So in example 2a, I don't have an x on every term, and I don't have a coefficient for my x to the fourth, so there's no GCF for all three terms. Now, technically, this type of factoring, this x to the fourth plus 8x squared plus 15, we haven't really seen before. But if the first variable is the square of the second variable when it's in standard form, when you've got a trinomial, then it's actually a quadratic function. So x to the fourth is x squared squared. So we have a quadratic function, so we're using that T-table method because the lead coefficient is 1. This works a little bit differently, so stick with me until we get to the end of this factoring if you're confused right now. So if the lead coefficient is 1, we're going to use the T-chart. So remember, that's the one where we think about what multiplies to 15, our constant, and what adds to 8, the coefficient of your middle term. Well, off the top of my head, 3 times 5 gives me 15, and 3 plus 5 gives me 8, so it looks like I found my 2. Now there's two ways to factor this. With the T-chart method, there is a shortcut where you can just throw it into the two binomials, or you can use the AC method, which we'll see on part B, and factor by grouping. I like the shortcut. So this time, to multiply to x to the fourth, I can't use x, I have to use x squared. So x squared plus 3 times x squared plus 5. So remember, when it's the T-chart method, whatever numbers you find for your chart are the numbers that you'll put in your binomials. I can always check to make sure that I got the correct answer by multiplying it back. So if I do x squared times x squared, I get x to the fourth. X squared times 5 gives me 5x squared. 3 times x squared, and 3 times 5. Combining my like terms, I get back what I started with which means that this was the correct factored form of x to the fourth plus 8x squared plus 15. One more example. Step 1, always look for GCF first. 3, 11, and 6 have no common factors, so moving on to step 2. Is the variable of the first term the square of the second? Yes, this is in our normal quadratic form. Lead coefficient is not 1, so we're jumping to step 4. We have to use the AC method, and then we have to factor by grouping. AC method is similar. We start it with the chart, but instead of multiplying to 6, the constant, we multiply A times C. So we're multiplying to 18 and adding to a negative 11. First numbers that come to my mind to multiply to 18 are 6 and 3, but that won't add or subtract to 11. 9 and 2 multiply to 18, but they would add to a positive 11. So I'm just going to make them negative. And then what we do with those two numbers once we find them, there's no shortcut on this one, is we rewrite that 11x as negative 9x minus 2x. And then we factor by grouping. So common factor for our first two terms would be 3x. Dividing that out, I'm left with x minus 3. GCF for my second two terms is 2, but I notice that the signs are backwards for my second two terms, so I'm going to factor out a negative 2, because remember, what you want is inside the parentheses, that binomial, to match. You want it to be another GCF. So if we factored out a positive 2, they would be opposites. So now looking at term 1 and term 2, we have a GCF of x minus 3. Factoring that out, I'm left with a 3x minus 2 for my second term. And your U-try problems.